So welcome to the session back again. So I will just first explain you how you can do the selection sort based on the example I have done. And then I will introduce to you the linked lists and how to write your first linked list program. Okay, so if the time permits, we can go deep into the linked list, but let us see what will happen. But I will start today about linked list. Let me share my screen. So first of all, we do the selection sort. Okay, now let me go into this. Right. So we have these variables, right? We have these variables which are need to be uh, satisfied with values. And by this time, you might have observed that if this blue color is a border, for every border increment of the value, whenever we are incrementing the border value, again the left hand, right hand will be set and the right hand is iterating from that particular one. So by this, you might have understood that because we are increasing the border value from -1 to 7, you might understand that this is one loop because the border is iterating through each index. And when border is iterating through each index, for one iteration, the J is going from particular place to the last. So this is another iteration. So not J, but according to, so I am using professional programming language, but I am doing like this. So the right hand is iterating from a particular position to the last. So this is another iterations. So this is another loop. So for every border loop, there will be a right hand loop. So by this, you can understand that we had something like nested loop. Okay, this is called nested loop. So I will write down these things. So first I will initialize, I will initialize the border with border is equal to -1 as I have discussed with you. So here for every border we need to set, so for every border value that is being incremented, we need to set the left hand, right hand and selection values, right? And in that, again, the right hand is going from a particular location to the end. That's what we are discussing, right? So let us keep everything in a loop of the border. So I will say while border less than length of L. Let us say that we need to first declare the list also, right? We did not give the list. We take the same example as I have discussed with you so that it will be live experiment for this. So 93851647. 938511647. Okay, 938511647. So this is the list I am giving. So considering the list, I think the length of the list is 8. So it will stop at 07. Okay. So we are starting our border at -1. So we are going up to the length. Okay, right. Let us experiment it. So what is the next thing I need to do? The once this is done, I said that our left hand index value should be in the selection. So that means we need to keep 0 here. And after keeping 0, this is the one we need to check. Okay. But how do you need to check? Because every time you are checking the same condition when your right hand is moving. Right hand is not stationary, right? So it is at one position. Next, it will be at two position. Every time you need to check with the selection. First of all, you move the index of the left hand to the selection, then you compare the selection value and the right hand. Again, the right hand increments. Again, you check this selection and the new right hand. Again, the right hand increments. So I think everything should be done in a loop. So before that, what I will do is I have to set these two things. First, the left hand should be border +1 and selection will be the left hand. So for that, I will write the code. So what I will do, yeah, left hand is equal to border plus 1. So this is what I have done, right? So the next thing is selection is equal to every time left hand. So our selection will be the left hand now. Now, because we want iterations for j, it should start at particular position and at until end it needs to go, and in between we need to check the condition, right? So I can use a for loop. While also I can use, but I'm using for loop in a different way. So for right hand in range. So where does the range start from? Can anybody tell me? What is the initial value of right hand every time
Left hand
the
plus 1,
border
sir.
iterates? If the
Left
border
hand
is
plus 1, sir.
here, like 0, if the border is 0, the left hand is always equal to the left hand plus 1, or the border plus 1. What is the right hand value?
Left hand
Border
plus
plus 2.
Where should I keep the right hand here?
left hand plus one, sir. So 2.
Am I audible?
Yes, sir.
Hello?
Sir, sir,
Guys, can you reply me? Am I audible or am I telling to the ghosts?
sir, we are answering to you, sir. We are audible to you, sir.
Sir, in between your voice is being cut.
Okay. Okay. I'm sorry. I had a problem. Yeah. Thank you, Chakrini. Uh, I understand that. Okay. Right. Now I can listen to you. Now I can listen to you. There is some technical glitch, I think. Yeah. So the right hand should be the right hand plus 1. Okay. Sorry, the left hand plus 1. So what I need to do is the starting value will be left hand plus 1. So I was really afraid that I don't know whether my mic is audible to you or not. So I thought whether I am speaking like as if I am speaking to a ghost. So after all explaining all these things, if you say that, sir, you are not audible, it will be something difficult for a teacher to go again to the backside. Okay, right. What is the end point now? The left hand plus 1, it will start. The right hand will start at left hand plus 1. What is the end point for us? Up to?
Border.
Yeah, length of L. Okay, length of L. So up to length of L it will go. And then we need to write the condition. The condition that we have kept is for every iteration we need to check this one. So let us copy this if possible. Copy and paste it here. The condition which I thought it will be fine. Okay. So if condition I am done. So if this is true, if the L of selection is greater than L of right hand, that means wherever the selection is, if its value is greater than wherever the right hand is, then I think we should say that selection is equal to right hand. So here we are actually comparing the elements, and based on the elements, we are now taking down the indexes. So the right hand and selection are actually having the indexes in their memory. If it is not the case, if this is not the case, what should I do next? So I think I need to swap it, right? So after the for loop, if it is not the case, nothing I can do. Just I just go beyond that. The right hand will be incremented. If this is the case, like L of selection is greater than the L of right hand, I think I can do something like selection is equal to right hand. Finished. If the right hand reaches to the end of the loop, that means it reached already to 7. The loop will be skipped. What is the next step that we are doing? Can anybody tell me?
Swapping, sir.
Yeah, swapping. So the simple thing is that we can swap like this. Selection, comma. This time left hand swapping, right? left hand. This is the thing that we have discussed. So again, L of left hand, comma, L of right hand. Okay, sorry, it's selection. So L of selection is equal to L of left hand, L of left hand is equal to L of selection. This is what we are doing. And before we go to that next, so you remember this, you need to increment the border. Border is equal to border plus 1. So while loop actually expects that. Somebody asked it in the previous section, right? In the previous session. So it should be like, if you are using for loop, there is no need of the 17th line. But if you are using a for loop, you need the 17th line. So I think everything that I have discussed with you in the previous session has been written here practically as program. And let us see what will happen while we execute this.
Sir, you need to change the name of the list, sir.
Okay, I put like, I copied directly as L, right? Thank you. So I'll put it like L. So there to make you understand that this is listed. Otherwise, if I don't keep capital letter, it is looking like I. So I kept it like capital letter and I copied the same thing. Thank you. L. I think everything is fine, right? Okay. Now let's look into the memories and all. So we have our list ready. So border is -1. Left hand, right hand selection. Okay. So it's going through. And it is repeating until that. So 1 came to the front, right? So 9 went to the 4th position according to what we have discussed, and 1 came to the front. So this is the realization. So when we see that the output is getting correct, so this is called realization. So the before one, but that we have explained in the class is called imagination. So when you imagine something, you need to understand how to imagine it and how to get through that. And after you are confident that I can realize that one, then you write the code to realize exactly what is happening in the computer. So next we will go through that. So I think 3 is in its position, so no need. So it will go to the end of the loop. And again, the while border is increasing. This time, the next one will be 4. Until it finds 4, it will not put it in the selection. Okay, then fine. So 1, 3, 4 has been done. So like that, the final output will be 1, 3, 4, 5, 6, 7, 8, 9. So there is a problem here. Can anybody correct this? At the 15th line, the problem is saying that I don't have this selection or the left hand, because left hand is border plus 1 naturally. So because border enters up to 7, right? So what happens now? Because the border comes to 7, it will be said as left hand is equal to 7 plus 1, 8. So what should I change so that the 15th line will not be an error? I hope you are understanding what is that error. Now debug it.
Sir, in the 5th line, border is less than length of L minus 1.
Yes,
Can that
yes.
work?
So if we keep like this, so by the time border comes to 6, it will stop there. You know, after 6, it will stop there, because if it comes to 7, it comes out of the loop. And by the time everything is fine, because the last number is always the highest number that we get. Okay, by the time everything is arranged and only one number is left, there is no need for you to compare also. So leave that last one aside. So you are going up to less than minus means less than 7. So it will stop at 6. Okay. So at that point, this is legal, because the last thing the loop enters is the border is equal to 6. So left hand is equal to 7. That's fine. By the time border comes to 7, we are coming out of the while loop. Okay. So this time it should not show any error. Yeah. So 1, 3, 4, 5, 6, 7, 8, 9. Everything has been arranged and it doesn't work. And you can also test it for equal numbers also. For example, if I give an equal number 9. So you somebody asked in the in other section, right? If you have equal numbers, what will happen? You can apply the same logic, they will work fine the same way. See, it will, the both numbers will be coming to the last. You can also test your algorithm for accepting the equal numbers also. Okay. So this is all about selection sort. I hope you understand. You can do it on your own next time. Right. So you have your, exercises ready until tomorrow. I see still, I don't know how many people have used it. I said that you need to do it in the VPL itself. Please do it in the VPL because I find only 20 people submitting. So, see, for the first time when you are submitting it by running it, I know that I can know that you are doing in the VPL itself. But if you are not doing and sitting idle, I will, or you are doing somewhere else, I can easily estimate that you are just time passing it. You are not doing it, and later on you are trying to copy. So you show your hard work there itself. Don't take other editors or IDEs and try to do there. Please try to do in the VPL itself. Then I can know at what point of time in which line you are. Right. Let us go for linked list. So let me ask you, what exactly is a list? Don't think about Python's list. What is a list actually?
Combination of elements, sir.
Okay, that's a combination of elements. That's correct. So it's a combination of elements, but we don't know in what way it is arranged. So they have named into two ways. One is array. Array is something like you have contiguous memory allocations. So they are side by side. If each integer, if it's an integer array, is occupying 4 bytes, their memory addresses will be in a sequential way. For example, the address of the first element is 1101, the address of the second element will be 1105, and the third one will be 1109, like that. It's a sequence. Why I am calling this a linked list? Why this is called linked? Of course, they all come under the lists. The main class itself is the list. But one is called array and the other one is called linked list. So here, why I am calling linked, because you know that if you are imagining this train, we have link bogies, right? Why we say linked? The reason is they are getting connected with something, some link. In the same way, if your values are randomly arranged like this, each one having different address. This is 1101, this is 3161, this is 4132, this is 6513, some random addresses. Wherever the free space is found, if the value is kept there. And there should be some mechanism where it is connecting to from one point to other point. So after this element, and after this element, this element. This is how your things are actually linked. So this is one element that you have. This is another element. They're all arranged in random locations. And these random located values are sequentially connected one after the another, so that you can go through each one. So you can read the first value and based on the link, you can go to the second value, read it, go to the third value, read it, go to the fourth value, read it. This is the reason why I am saying these are called linked data, or you can also say the whole thing as a list, and you can say it is a linked list. Then you might ask me, what is the exact meaning of the list? So I can say these are the sequential data. So you can read the data in a sequential or linear manner. Linear in the sense one after the other. After visiting this, you know that you should visit this one. This is called linear. So for example, you are sitting in a lab and if people have instructed you to sit in a line according to the roll numbers. So I can come to you in a linear fashion, right? So I can go because you're all connected, whether you are sitting in a straight line, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, like that, or you are sitting in a random position because you want to sit with your friends. So one will be in the last computer, the two will be in the first computer, like that. Anyway, you are all linked with the roll numbers because I'm going from one another. Even though you are randomly sitting or sequentially sitting like arrays or whatever it might be, I still need to go in a sequential roll number one, roll number two, roll number three. It's a linear fashion. From first to last, if you are going in a way in which you have to go, this is called linear. But if you are sitting random and I am only going through all the benches in the line, for example, there is a row in which there are 10 computers and 10 people are sitting and nobody has sequential roll number. So the first computer has 1, the second computer has 10, the third computer has 21, the fourth computer is having 18, but still I am going row wise. So this is called non-linear. That means I am not attending to you as 1, 2, 3, 4, 5, 6 as sequential or linear, but I'm going in non-linear. So first 1, then 21, then 18, then 51, like that I am going. So non-linear data structures are different. As I have told you, they are called trees and graphs. So they are not sequential. You can go from anywhere to anywhere. And there is no compulsion that you need to go for. If you need to go to 3 here in linked list or array, you need to go through 1 and 2 and then go to 3. This is linear, entirely linear. The traversing of linear arrays or lists are very easy. So you need to remember that a list is a collection of data which can be traversed in a linear form. And this is divided into 2 ways. How do you traverse in a linear form? It is based on the arrangement of the memory. The arrangement of the memory is done in 2 ways. This is contiguous memory allocation, where all your elements sit side by side. This is the random memory allocation, where all your elements will be at random positions, but still they are linked with one another so that you can traverse sequentially or linearly. The difference is only the memory arrangement, but it is not about the way you traverse. The way you traverse defines the list. Like if you are traversing linearly, then definitely we need to call it as list. And if it is contiguously arranged, then it is called array. If it is randomly arranged, then it is called linked list. I hope you understand these differences between them. Then let us go through the mechanism. What type of mechanism we would have here? The mechanism is linked list is always considered as not one single element, but it is a node. The node consisting of value and its next address, NA, next address. So the same arrangement I will do. For example, I am keeping the first value as 10. So it is having 2101 and initially it will say as null. And I'm creating some other value in a random location. And I will say wherever the free space is there, I will put 100 here. And I will say this is the next element of my list. This is at 6121 somewhere. This is also null. Then what you do, you need to connect them. The next procedure is to connect them. So here you will write something like 6121. So now it is getting connected. So it will get connected to this. Because you are saying the next address is 6121. After reading 10, you will say go through the next address. It will immediately reach to here and read the next value 100. This is how your linked list mechanism of connecting each thing will be done. The last element will always have null value. Remember that. The first and last but one nodes will always have the addresses with them. Addresses connecting to the next node. Because the last element, last node is the end of your list, so it will have always null. That means this is where you are trying to end your reading. Linear reading. That means you are going or traversing through the list in a linear way. So I think you understand that. Okay. So the same example, which I don't know whether I have told you or not, you can just remind yourself once again if I am teaching you. So if I have gone through my relative's village, so you all know that all the surnames and one family will live in one street in our old villages. Actually, they are not randomly located. So this is the road, and I can visit from one place to another place. I know that after this place I need to go to this house, and after this house I need to go to this house because they are all relatives. Coming to cities, I think I have explained this. Coming to cities, your friend's house will be here, and you visited your friend's house, and after sitting for some time and chit chatting, you ask your friend to name the next friend's house. So you will give the address of the next friend's house, and based on the address that he gives, you visit him. And after this, you have some tea or coffee or something, and then he will allow you to go to your another friend's house by telling the address of the next friend. And if he is the last friend, he will never tell anything, and he just drops you at the railway station, and you say goodbye and get out of the city. So these are randomly located. In city, we friends or family never sit together, right? We have random locations. One stays in Visakhapatnam, it means if Gazwaka, one stays in Sitamadara, one stays in the steel plant, something. Different locations they will stay, not like the villages. Just a second. I'm sorry for this. Okay. So this is how you can say that this type is called an array, where you know that immediately I need to go to the next. Nobody needs to route you. One by one, sequentially you can go. But this type is called linked list. The reason is you don't know where the house is. You need to find out the address of the next house from your previous friend. And after coming here, you need to find the address of the next friend from here and come back to this. And this is how you actually connect with one another. That's what I'm saying. So when you visited this node, having 2101 as address, its next address column will tell you that you should visit 6121 next time. So it comes here. And now here it is null. So it sees that it is the end. But if it is again connected to something else, first I create a node, maybe 1000, and I have something like this, and this is 7161. So here you will write 7161. So based on this, it finds out the next address and visits to the next address. So this is how you linearly read all the data based on the next addresses of your present current node. One by one you can visit. Then my question is, you might ask me, the more advantage is with arrays. Why do we consider linked list? Then if you have the doubt, I need to clarify it to you. See, all the time you are just spending on your single computer, right? You're just spending on your single computer. Doing something here by typing, okay, sitting and typing something, right? And your program will consider your RAM as single one, and it will completely allocate all the RAM to your process. There is no need of memory shortage or something, right? This type of problem will not appear to you. I will tell you when the memory shortage or memory error will occur or some time will take place. There are arrays which are called dynamic. I will also tell you when we come to the C programming coding section. First, I'm concentrating on finishing up this portion. You have two functions called malloc and calloc. These are called dynamic memory allocations. Okay. So memory allocation, which is dynamic, having two functions, malloc and calloc. So what do you do with this dynamic? Actually, you create an array like this, right? In C programming, I said it should be static. If you are saying 5, the 5 should only remain. Whatever you do, like insertion, deletion, should be done only among this 5. No extensions like lists that you learned in Python. Arrays are fixed. But there is a way in C programming where you can expand it. So what you can do is, you can create an array based on dynamic memory allocation. That itself says that it is not static. Static is fixed. So this is static. This is dynamic. So you can still expand it. So first you only want only 0, 1, 2, 3, 4, 5 locations. So you have created it. And next time you want to create another 5 locations so that you want to expand your array. What happens, I will tell you. This function is called realloc in C programming, realloc. Once you created your array using malloc, like this, 5 elements. The next thing that you want is using realloc, you want to expand it to another 5. Because the RAM is yours, there is no problem for you. The remaining spaces are free here, whatever I'm dotting. So you can simply expand here itself another 5. You are now very happy. So because it expanded it, not a problem. Now it becomes 10 elements. So using dynamic, you can expand beyond what you have already created. So a dynamic array in C programming can be expanded, not the static array. Like your list, it can be expanded using a function called realloc. So for this, what it will do, it will fetch the continuous memory allocation. If it is there, then it will give. Otherwise, it will not. Now coming to your original applications. When you work in companies, all of you work on single RAM. So you, your friend, maybe you are called X and your friend is called Y and another friend is called Z and another friend is called A, are all working on their computers with the terminals. And these are all connected to this. So these are actually the terminals, not the real computers. They all work. That's why you can observe that your brothers and sisters generally work with the laptop, right? Which is connected to their company. It's not working on their own laptop. So these are all connected to the single memory, which acts for them. Now, for example, as X, you have created a dynamic memory allocation of 0, 1, 2, 3, 4 values. And you want to expand it. So this is created in the RAM, okay, which is common to. Now what happens, I will tell you, see. I'm just telling it to you because not every time arrays can be implemented. Now, this is what you have created. Maybe 1, 2, 3, 4. So 0, 1, 2, 3, 4. So 5 elements which you have created, which is created by X. And you want to expand this one because you want to put another 5 elements in extra to it. And in between, meanwhile, your friend came very fast and he has implemented a variable called b is equal to 10. By the time before you are expanding your array, just a few milliseconds earlier, your friend has run his program, and hence it is fetching for a free space and kept b here. And this is, so if this is your array A and he kept B as a single variable, and this is kept by Y. Now, can anybody tell me, if I want to expand, what will the computer do to me? Any guess from your side?
Sir, actually it fetch for the addresses, but it's not there. So it's didn't allocate, sir.
Yeah. So do not allocate something very bad when a programmer asks a computer to allocate. So the computer feels very shy. So what it will do, it will now fetch. So you want another 5 to be expanded, right? So it will now fetch for a memory location where it can accommodate the old 5 plus new 5 and a total 10 values. So now take time for fetching where it is available. Okay. Next, after it found out, first it needs to copy the whole memory and put it here. So it will copy 0, 1, 2, 3, 4 from the old memory, and then it will create the expanded memory 5, 6, 7, 8, 9. Okay, expanded memory. So you need to have copying time, fetching time, copying time, and after that expanding time. So it is creating 5, 6, 7, 8, 9. So see how many how many times it is actually taking. Fetching time, copying time, expanding time. This leads to the program's confusion. So that means if your program should work at 1 millisecond, for all these things, it might take 3 milliseconds. It might take 3 milliseconds. So this is very bad for you. So this is where you are working in parallel environment. So not you and your computer, one memory will be given to all of you, one big hard disk and one big RAM in which you all work together. Maybe that RAM, something like some hundreds of GB will be there. A series of RAMs will be collected together and kept connected by a bus, and they act as single RAM. So all the employees work on a single system, which is stored in your office. You might be working with your laptops, but you are actually working on single memory. So memory efficiency is very important in this case. Wasting this much of time and allocating, getting this much of memory every time takes a lot of time for your execution. So for this, we have a beautiful solution that is linked list. To linked list. The simple thing is now I started to do it. So he is giving the first value here. For second value somewhere, fetching for 10 values or 20 values in restriction, 20 elements or 10 elements is very difficult than finding a small location for your small variable. So first you have kept some 10 here and initially it is null. You want to add another element. Okay, wherever it is free, just find out. That's all. There is no that much of time it will take to fetch something. Because you are just putting one integer and one address. How much of memory you want? Because address is there and integer. Maybe if it is occupying 4 bytes, 4 or 8 bytes, it will occupy. That's all. Finding 8 bytes is not a very difficult, right? Just a second. Yeah. Finding a space for 10 elements is difficult, or finding a space for 8 bytes which stores a single element is difficult. Can anybody answer me? Which is difficult for you? Hello?
So finding
Hello?
8 bytes, sir.
Yeah, finding 8 bytes. That means, okay, don't bother about bytes. You want to store single element. Finding a space for storing single element is easy, or finding a space for storing 20 elements like in the previous example, 20 or 10. Is it easy? Which one is easy for you?
One element, sir.
One element, naturally. So that is the reason linked lists have come to existence. Because they are randomly arranged, they are not sequential. They are not restricted to be sequentially arranged. ఒకదాని తర్వాత ఒకటి ఉండాలని రిస్ట్రిక్షనే లేదు దానికి. సో ఇన్ దట్ కేస్ ఇట్స్ సింపుల్ దట్ యూ క్యాన్ జస్ట్ సెకండ్. హలో, am I audible? I had an internet problem here.
Yes, sir, you are audible, sir.
Sir, you're audible, but exactly when you're saying some important points, your voice is becoming blur, sir. Exactly when you're saying important things, but you are audible, sir.
Okay. It is saying like the connection error is there. Unable to draw anything here. Just a second, I'll bring my phone and I'll connect it. I hope it should work now. Okay. Right. Okay. Now finding an element space is very easy for you. So what X will do without any disturbance, even for example, X has created this one, an element, first element, and it is null. And by the time Y has created B is equal to 10 in his program, and it is stored just beside it. So B with 10. Okay, man, not a problem. There is no need for you to copy this one and paste somewhere else. You just need to have something. So X has created another element here. So he might have created 121 something, and it is null, and its address is 6101. And this one is 2101, for example. So to just connect it, there is no need for you to copy. So you are eliminating copying and expanding time, and you are just fetching time and putting the element. That's all. So what you do here, you simply rub this null and you keep something like 6101. So that means it is now connecting to this one like this. See, it is now connecting to this. No need of picking off this one and pasting somewhere else so that the other element should also be accommodated along with that. You just connect it, that's all. And if you created another element somewhere else, okay, this time this I am creating it. So this time I am storing something like 150, and this is null. So this is 7101. And the simple thing that you do is you just make this one as 7101 as the next address, and hence it is connected to the next one. That's
Sir,
all.
sir,
Yeah, tell me.
small dot, sir. Sir, if it is in order, it is easy to find for the computer, no, sir. If it is in a way somewhere, it will be taking time, no, sir. So search where is the another next one.
Yeah, that's what the thing we need to discuss is. It's all depending on the scenario. So if you want a fast output by just reading all the elements very fast, then you should not go for linked list. You should be going for arrays. But if there is an memory problem for you, like what I have explained you earlier, then there is also an alternative for you that is called linked list. Because arrays are very fast at reading. But while you are keeping an array, whether it is dynamic array or static array, it needs to fetch a space where all the five or 10 or n number of element space is there or not. So fetching times take some time, because in your computer also you might see that number of processes are running at back. So it has to go through whole RAM to find out where n number of element space is there for you. So this is most easy for you, because you create somewhere some element, and you find out some space for some other element, and you just link it.
Sir,
Yeah, tell me.
sir, it means it will be taking same amount of space, means sir. Here anywhere it is stored, but it will be saying same. It is
Same amount
taking
of
no, sir.
But finding, for example, I will tell you. You are three best friends. Okay, some three best friends are there. You all want to stay beside each other. That's all. Can you find a house where three houses will be beside each other so that you all can stay at a time? You cannot find, right? You have to roam around the city to find out such a house where all the three houses will be side by side and all the three houses are vacant, so that you all friends should stay there. But another case I will tell you. Now you thought dynamically. Okay, my friend, even though we are best friends, we can meet every day. So we will sit in random locations and we will have a connection through WhatsApp or somewhere. So we can have a chit chat or so on. So this is easy, right? You can one vacant house somewhere else, and your friend can find some vacant house somewhere else, and you all get connected with each other. Which one is easy? Can you tell me based on this example?
Random one is better only, sir. Means we can get easily vacant houses.
Yeah,
First,
that's what I'm telling. So memory is equal, of course. It is occupying the same memory. I will agree with you. But fetching what we say, a free space is very easy in linked list when considering the arrays. That's why I said it's all based on the scenario. So in what scenario you are there? For example, you are only working on your single system. Why do you go for linked list? You can go for arrays. But if there is a scenario where finding n number of element space is very difficult for you, then you can go for linked list. That's all. But I always agree with you that arrays are very fast than considering the linked list, because it has to go to each address, fetch that one, and go to the next one. So
it means you always using a linear one is not we can use that according to the situation, no, sir. It is not that we
the situation.
always linear one.
This is the advantage and this is the advantage. Advantage lies based on the situation. Okay.
Yes, sir. Okay, sir.
Yeah. So this is all about linked list, and I think the time is up already. It's 2:55. So tomorrow we will do the first coding for linked list, and we will go through different aspects like single linked list, double linked list, and circular queues something. Okay, circular linked list. Okay. So bye bye for today.
Thank you, sir.
Okay, bye.
Thank you, sir.